Household electricity. Right. In the laboratory, you tend to use cells and batteries, and this is known as DC or direct current. And in direct current, the electrons move in one direction. The current moves in one direction. Okay. In AC, otherwise known as alternating current, what you actually have there is the voltage is constantly changing direction. They go one way, then the other, one way, then the other. And they do that at 50 hertz, 50 cycles. It keeps changing direction. And the mains value of AC electricity in the United Kingdom is 230 volts. You need to know that. 230 volts, 50 hertz, and constantly changing direction. This may be shown in a diagram like this. This is supposed to represent a cathode ray oscilloscope. I do have a video on cathode ray oscilloscopes. And what this is showing you is the green line shows DC, and its value stays the same. It stays above the middle point of this diagram here. There's like a middle line going across there, and it means it's always got a positive voltage. It's always going the same direction. Whereas AC is sometimes positive, sometimes negative, sometimes positive, sometimes negative. In other words, the red line passes above the middle line and below the middle line, above them, like constantly changing. And that is what AC does. It's constantly changing the direction of the current. You need to know the wiring of a plug. This tends to be a foundation question. You need to know what the colours stand for, so you're just going to memorise this. The other thing to point out is the fuse is on the live wire. Very often they'll frequently ask you what's the fault with it, and it may be the case that the cable grip is not being held in position, or you may have a bit of loose wire touching a couple of terminals there. They very often have a question along which bits are insulators. Well, the plastic casing is, the rubber is an insulator, and the conductors in this case are copper, which is inside the wire, and brass. The pins, which are basically the sort of goldy coloured bits of the plug, are made of brass. Okay. Sometimes they'll ask you to consider these cables. They'll say, why does the cable on the left have 3 wires in it and the one on the right have 2 wires in it? If you notice, the earth is missing from the 2-core cable, and that cable would be used if the device is made of plastic. If the outer casing is made of plastic, then you don't need an earth wire. Again, there's a video later on explaining why, but you will have an earth wire if you've got a significant amount of metal casing to your device. The earth wire is attached to the metal casing of the device, and the other end goes into the ground, and that's why it's called the earth. Right, what you need to know there is direct current, that's current in one direction. AC alternating current is changing direction. The voltage becomes positive, negative, 50 times a second, 50 hertz, or 50 cycles per second. That's probably a better thing to say. It's 50 cycles per second. It's 230 volts AC, mains electricity. It's constantly changing. You must know what we mean by earth, live, and neutral. The earth is at 0 volts. The live is at 230 volts AC, so it's changing, and the neutral just hovers ever so slightly around 0 volts. It does fluctuate a little bit. It just goes up and down, up and down, up and down, but very, very small amount. It does the neutral do it. And you need to know what we mean by 2-core cable. That's the one with no earth wire, and 3-core cable, which has got the earth wire. 2-core cable is used if your device is made of plastic, and that is known as double insulated. Make sure you know that. Double insulated. If it's got 2-core cable, it means it's made of plastic, so it's therefore double insulated. 3-core cable is for other devices that have perhaps a lot of metal on the outside. And that there is household electricity.